All right, my little freshmans and woolmans, this is Harriman coming at you, teaching you a little bit about balancing chemical equations. Now, first of all, this might not be the easiest method for you. It works really well with my classes throughout the years of teaching balancing. Um, and there's three different ways that I do it, or three different methods that I teach in a way, okay? Now, if you don't like these methods, you're more than welcome to search online, find another method, talk to another teacher. Lots of good methods out there, okay? Well, the first method I'm going to teach you is what's called the traditional method. Someone right here, traditional, if my pencil works. And these are for the traditional chemical equations. All right, so let's give you a chemical equation here. Let's give you a simple one, okay? How about let's start off with a little methane gas, CH4, plus a little oxygen gas, which creates or yields carbon dioxide and water. Now, first things first, you got to make sure you understand that each of these are a chemical formula. They're a compound of some sort, whether molecule or compound there. Methane gas, oxygen gas, carbon dioxide, and water. Now, you should be able to name at least the carbon dioxide, oxygen, and water, which is dihydrogen monoxide, if you learned it from the nomenclature of chemistry in previous lessons. But today we're going to show you that once an equation, once all the formulas are balanced in the sense that each one is correctly done, whether it's an ionic or covalent bonded compound, the equation's made for you. Now let's balance it. Now, what do I mean by balance? Let's talk about a couple things here. First of all, the left side here, because it's a single yield, is the reactants, and the right side are the products, all right? Each little number underneath the element to the bottom right are called subscripts, and they represent the number of atoms. Now, how I teach chemical balancing, I always write the number of atoms per element down below. So let's start. Well, if you don't see a subscript here, that's automatically a 1. For hydrogen. Now, common mistake, people look at this and they'll put 4 for both. That is incorrect. Look right under the element. Okay, 1, 4. 2 oxygens, 1 carbon, 2 oxygens, 2 hydrogens, and 1 water. Now, when we balance chemical equations, what we have to do is we have to satisfy a law called the law of conservation of mass. Okay, what that talks about is it explains, or part of it explains, that the atoms, specifically the type of atoms you start with, you must also end with those type of atoms when you end with. Now, compounds are going to change. That's what a chemical reaction is all about. It changes up compounds. But what happens is the elements individually still have to all be accounted for. We start with the reactants, we end with the products, and both the left side and the right side must be equal. Now, when I say equal, again, I'm talking about the number of atoms per element. So, like, for example, let's say that there was 10 carbon atoms total on the reactant side. Well, then we would need a total of 10 carbon atoms on the product side. That's the right side. All right, now, when we're looking at this, and the trick to balancing is, first of all, the only thing you can change on this is what we call the coefficients. The coefficients are the numbers that come in front of the compounds, okay, the individual formulas. I'm not allowed to add elements or take elements away or add subscripts. Okay, you're not allowed to do that. You're only allowed to change the coefficients, the number of compounds there are. All right, so now when you start a process like this, me personally, I like to look at an equation, and I like to start with what I call the big ugly, okay? I look for the ugliest, meanest formula on there, the compound on there, and I start with it. It tends to be easier. Notice, and how do I know what's a big ugly? Well, if they have more than one different type of element. Well, here there's carbon and hydrogen. Now, I know there's 1 carbon and 4 hydrogen, but 1 and 1, different elements. There's just 1 type of element here. Here there are 2 type of elements. 2 type of elements, okay? 2 type of elements. So I would personally leave oxygen to the end. Now, you don't have to do that. However, I found it makes it much more challenging to start with a simplified, or there's a simpler compound here, which is oxygen gas. Now, what I like to do is I'll start with the big ugly and I count the number of atoms. Well, I have 1 carbon on the left. Now, I don't draw this line very often, but I'll do it here. This line shows the left side from the right side. This side has to equal this side. All right, so I look at them. 1 carbon, 1 carbon, We are so far balanced. Now, you hear me say so far because so many times compounds will change as you're balancing. Me personally, I always start left to right every single time I'm balancing. That tends to help with the easier chemical equations. So I have one carbon, one carbon. We're good. 4 hydrogen, 2 hydrogen. Now we have a problem. These numbers have to be the exact same. I need 4 hydrogen right now on the left, and I need a certain number on my right, 4 on my right. So I look at the numbers 4 and 2, and I think, well, what's the lowest common multiple they could both go into? And a 4 and a 2 can both go into 4. So I don't have to mess with this one. It's already 4. But I have to put a number in front, a coefficient, a multiplier that will multiply this hydrogen to match the 4. Well, obviously, what times 2 gives you 4? 2 does. So I added that 2. Now 2 times 2 is 4. Now listen, this is for the whole molecule, the whole compound here. So that means not only do I have to times the hydrogen by 2, but I have to times the oxygen by 2. Because the coefficients are telling me I have 2 water molecules here. So 2 times 2 is 4. 2 times 1 is 2. So I start back again. I always look left to right. 1 carbon, 1 carbon, 4 hydrogen, 4 hydrogen. Good so far. 2 oxygen. Now be careful. Let's count the ones on the right. 2 and 2 make 4. There are 4 total oxygens on the right. Even though they're in 2 different separate compounds, there are 4 total. So we have to find a common multiplier of 2 and 4. Well, 2 and 4 can both go into 4. So how do I get that? Well, we don't mess with this side because it's already 4. We have to multiply this by 2. 2 times 2 is 4. Well, let's see if this works. 1 carbon, 1 carbon, 4 hydrogen, 4 hydrogen, 4 oxygen, 2 plus 2 is 4 oxygen. This is a balanced chemical equation. We have subscript-wise 1, because if you don't see a number, it's automatic 1, kind of like subscripts. 1, 2, 1, 2. Now, there are some times when you are balancing chemical equations, when you're doing the back and forth tricks, you'll come up with numbers, coefficients that are a little bit higher than they should be, but yet the balancing game works out. I'll give you an example. Let's say you're balancing, and let's pretend all of a sudden, coefficient-wise, you accidentally get a 3, and then somehow you get a 6, and a 3, and a 6. You times each of the molecule or the atoms, and you come out to exactly the same amount of atoms on the left and the right. However, like in math, we like simplified answers. So what can you simplify 3, 6, 3, and 6 down to? Well, you can divide them all by 3. So divide by 3 becomes 1, 2, divide by 3 again becomes 1, divide by 3 becomes 2. So the coefficients 1, 2, 1, 2, which match 1, 2, 1, 2. Again, you only need to do this step if the numbers up here can't be reduced by a single whole number. All right, so that's the first traditional. Let's look at another type of traditional one, okay? Let's put this paper up just a wee bit, and let's look at another one. Let's go to aluminum oxide plus chlorine gas yields aluminum chloride plus O2 gas. Now, looking at this, seeing how I was naming those, you should be able to name these compounds. If you are unable to, you missed that learning in a previous lesson. You need to go back on YouTube or talk to your teacher to be able to figure out how to name them. We call that the nomenclature of chemistry. All right, here we go. So again, we start with our steps. I'll pause for a sec. Let's see if you can do it. So go ahead and pause your video. See if you can number them. All right, welcome back. Let's see how you numbered them. Well, I have 2 aluminums. Now, these are L's, okay? These are how I write my lowercase L's. And I know that this is a single element because capital letter, lowercase letter. So uppercase, lowercase. That signifies just one element. So 2 aluminums, 3 oxygens, 2 chlorines, 1 aluminum, 3 chlorines, and 2 oxygens. Okay? Now, again, our goal to balance is to have the left side number of atoms per element equaling the right side's number of atoms per element. All right, so again, I personally like to start with the big uglies. You don't have to do that, but if you want to start with chlorine and oxygen, knock yourself out, but it is much more difficult. Okay, it's tougher. All right, so 2 aluminums, 1 aluminum. All right, so what does 2 and 1 can they both go into? They can both go into 2. So to change that, to fix that, we'll put a coefficient out in front. 2 times 1 is 2. 2 times 3 is 6. Do not forget about the second element. This is a common mistake with balancing. They forget, hey, I put a coefficient out in front, but they forget to multiply the second number, or sometimes the first. Remember, coefficients create more compounds. This is saying we have 2 aluminum chlorides. Okay, so let's count. I got 2 aluminum, 2 aluminum, 3 oxygen, 2 oxygen. Well, crap, those don't match. Well, what number, lowest multiple, can 2 and 3 go into? And the answer is 6. 2 and 3 can both go into 6. Now, how do I get, because we're comparing oxygens. So how do I get this 3 to a 6? And how do I get this 2 to a 6? Well, this 3 I would multiply by 2. And this 2 I would multiply by 3. Now again, because I put the coefficients out front, we have to change. 2 times 2 is 4. 2 times 3 is 6. 3 times 2 is 6. All right, so our oxygens are balanced. Let's count again. We'll have 4 aluminum, 2 aluminum. Well, crap, a second ago, they were fixed. But now, because we're balancing going back and forth, it changed. Balancing a lot of times is like just a gigantic puzzle. You keep trying things in pieces until it works. So now we have to change this. Well, what can 4 for aluminum and 2 aluminum both go into? Well, they can both go into 4. So I don't have to mess with this side, but I got to multiply this. Now be careful. You always look at what you start with. We have 1 here. So to change this, I have to multiply 1 by something to get to 4 aluminum. So it's because we're comparing aluminum. So I cross off 2 and I put a 4. Because 4 times 1 is 4, and 4 times 3 is 12. A common mistake is you will multiply 4 times a 2 and put 8 here, and that is a common mistake. Do not do that. Always multiply by the original. If you got to do that, maybe make a little underline to remind you. Okay, let's see what we have. 4 aluminum, 4 aluminum. Yay, good. 6 oxygen, 6 oxygen. Yay. And then 2 chlorine and 12 chlorine. All right, we got to fix. What can 2 and 12 both go into? And the answer is 12. So we don't need to mess with this, but we need to multiply this by 6. So we put the coefficient out front. 6 times 2 is 12. All right. Now, before you put your stamp of approval to make sure it's right and turn this answer in, double check that it's simplified. 2, 6, 4, and 3. And it is simplified. You can't divide those and get another whole number other than 1. All right. I'm going to give you one more traditional one here, and then I'm going to have you guys pause, try it on your own, then unpause and see how you did. Let's try lithium phosphide plus magnesium oxide, which yields or creates lithium oxide, that's my I's, lowercase i's, plus magnesium phosphide. Again, if you are not understanding how I am naming these, then you might need to go back again to a previous lecture or talk to your teacher. All right, go ahead, pause it, pause the video, try the problem, and go ahead and come back to me when you think you're finished. All right, welcome back. Hopefully you tried it and see how well you did. All right, well, let's start with our steps. We have 3 lithium, 1 phosphorus, 1 magnesium, 1 oxide, 2 lithium, 1 oxygen, 3 magnesium, 2 phosphorus. All right. Now that we wrote them down, if you look across the board, they're all pretty much equally just as ugly. So it doesn't matter where you start. I'm going to start with the left one then. Kind of like reading left to right in this case. All right, so with that little erase mark. So 3 lithium, 2 lithium. What does 3 and 2 both go into? 6. So I need to multiply this by 2 and that by 3. 2 times 3 is 6. 2 times 1 is 2. 3 times 2 is 6. 3 times 1 is 3. 6 lithium. 6 lithium. Yay! 2 phosphorus. 2 phosphorus. We're pretty good so far. 1 magnesium. 3 magnesium. Okay, we got to fix it. What can 1 and 3 both go into? And again, the answer is 3. So we don't have to change this side, but we got to multiply this coefficient by 3. 3 times 1 is 3. 3 times 1 is 3. 6 lithium. 6 lithium. 2 phosphorus. 2 phosphorus. 3 magnesium. 3 magnesium. 3 oxygen. 3 oxygen. We are good in the hood. This is a accurate, balanced chemical equation. Again, these are the traditional chemical equations. And I will come right back here and show you how to do the next form of balancing.